All right, so this is 70-3. It says graph the following and state the end behavior. Well, we're just going to focus on stating the end behavior. We're not really going to graph anything at the moment. But for number one, we said that it's helpful to look at it in a graph. So maybe plug what that would look like into a graphing calculator, right? So that's okay, but we're going to learn how to graph it without a graphing calculator. So x over 3x minus 6. All right. So for right here, it looks like x is going to negative infinity. Then x is approaching, here we have, what is that, 2? And it's approaching 2 from the negative side. Then we have x approaching 2 from the positive side. And then x is also going to infinity again. So now I have to state what is my y doing. So when x is going to negative infinity, my y is going to 1/3, which is the horizontal asymptote. When it's going to 2 from the negative side, it's going to negative infinity, because it's going down. When it's coming 2 to the positive side, it's going to positive infinity. And then when x is going to infinity, that's going to 1/3. Next one, number 2. Now, if you noticed when I went through and I did that, I kind of listed all the important things that my x was going to, and it was in any way going to infinity, right? So as x goes to infinity, or as my y's go to infinity, those are all the different things that I listed. All right, so x over x squared plus 1. All right, so for this one, it seems, okay, so it does some weird thing here, but it seems like it's approaching 0, and it's approaching 0. There's no infinities where y is going. So x is just going to negative infinity. X is going to positive infinity. From there, it seems like my y's are going to 0, which is the horizontal asymptote. And you can even verify it because the denominator has the largest degree, so therefore it's going to be y equals 0 for my horizontal asymptote. So you just do that over and over and over again. For number 6, look at a previous DI. So 70-2 or 70-1 for the domain. Remember, the domain is you set the denominator equal to 0, and you can categorize that as vertical asymptotes or points discontinuity or holes. And then the horizontal asymptote is you have to compare the degrees of the numerator and the denominator, and it's those 3 choices. When I say graph, we're just plugging into a calculator for now. Number 7, it says the cost in dollars to remove P% of the invasive species Ipuzuti fish from Sasquatch Pond is given by this statement. So it says find and interpret C of 25 and C of 95. So this is how much we're going to remove. So that means that if I put 25 in there, I'm saying if I remove 25%, this is how much it's going to cost. If I plug in 95, that's saying if I want to remove 95%, this is what it's going to cost. Now remember, C of 25 just means you're taking 25 and you're plugging it in for P. Right? That's like if C, sorry, that's a P. So C of 25. Oh my gosh. Now it says, what does the vertical asymptote at x equal 100 mean? That means that I'm removing 100% from the pond. Well, it's implying, if it's an asymptote, that you can't remove 100% from the pond. It's impossible to remove 100% from the pond. And it says, what percentage of the boozy fish can you remove for $4,000? So that's just saying your C of P is $40,000, and you set that equal to, and then you have to get P by itself. So then you solve for P. So this is, recall that in example 1.513 that the cost in dollars to make X OB is this. Okay, so that was, find the formula for the average cost. So remember, that's C of X over X. So you're literally, so C bar X is literally 100X plus 2,000 all over X. Interpret C of 1, so that means you're plugging 1 in for X or plugging in 100 in for X. This is how many DLPs need to be produced so that the average cost is 200. So that means 200 equals 100X plus 2,000 over X. Solve for X. Interpret the behavior. So now you want to plug this into the calculator, and it wants you to look at what's happening when X is approaching 0 from the positive, and then what's happening when X is going to positive infinity. So go ahead and plug those in the calculator to kind of take a look and see what's happening with that.